Good, everybody. So we are now by the differences of two squares. Just to recap, we have in grade 10, most important factorizations that we're supposed to remember is the first one is a common factor. First one is a common factor. Then after we have a common factor, we have a difference of two squares. Then we have a trinomial, which is also known as, we have the three terms and then the grouping and then the sum of cubes and a difference of cubes that goes together. We're going to do for the remainder of the session looking at the difference of cubes, the difference of two squares on page number 7. We're going to do that examples quickly, and then there's a few questions, and we're going to hope and try to get to the quadratic as well. If there's time, we're going to see if we can do the quadratic ones as well. All right, I'm going to do the examples. I want you to follow with me, and once I'm done with the examples, I want you, a few 5 of the volunteers to come and do it on the board for us. Good. So example number 1, we have there x squared minus 4. Now, what I'm technically doing this is the rule says a squared minus b squared can be factorized to the square of the first term, and then the square root of the second term, and then this repeats. All right, but the signs within the brackets are the same. All right, so I'm going to apply the rule. I'm just going to write it out for the first one a little bit different, so you might not be used to this, but I want you to see where this is technically coming from. So I'm going to open 2 brackets because I've already identified that this is a difference of 2 squares. I'm going to take the first number, which is x to the power of 2. So I'm going to write it down, x to the power of 2, I'm going to put it under square root. Then I'm going to take the second number, I'm also going to put it under square root, and then I'm going to repeat that in the second bracket. All right, like this. And then I put a plus sign there and a negative sign there. Then I just simplify these, and then I get my answer x plus 2 and x minus 2. There's my answers. Good. Why is it not showing x minus 2? No? Now you could have gone from the first step to the final answer because we already know it's but I just want you to see that step and where is it actually coming from. Now if I look at example number B there, number B we have 9a squared minus b squared. I'm going to open 2 brackets and I'm not going to show my step anymore. I'm just going to go to the answer here. So if I go straight to the answer, this is going to look like the square root of 9. What is the square root of 9? 3. And the square root of a squared is a. No, it's not 1, it's a. So I write that down, and then in now ask myself the square root of b. B squared is b and b. So that becomes a plus and that becomes a minus. Then you can see the example is quite easy for us. At number C, we have a to the power of 4 minus b to the power of 4. This answer is going to be the square root of a squared. And what is the square root of, not a squared, the square root of a to the power of 4. So that's going to be a squared, and then that doesn't look nice. Let me just erase that quickly. Hello, Mnr. So that becomes a squared, and then a squared in the second bracket, and the square root of b squared and b squared. And then what happens within the brackets? The one is a plus and the one is a minus. Now I need to check here. I'm not done because I can see in the second brackets there's also a difference of two squares. So I need to identify that here the first bracket is fully factorized because there's a plus. No? But the second bracket is also. So this one here can be factorized further. So therefore that now becomes the square root of a squared is equals to a, and the square root, so that becomes a plus and a minus b. Any questions? Yes. Yes. It says, the rule says difference between two squares. Why didn't we do it with the, that's correct question. We simplify further because there's a minus between. Do you see? So thank you for that question. You can't. No? Only, it's the rule says difference. So it needs to be, the first term needs to be a perfect square, and the second term needs to be a perfect square, and between them needs to be a minus sign. If it's not, if it's a plus sign, cannot factorize. Good. We're going to the next example there. Example number D. Now, this is a nice example because 2 is not what? Is not a perfect square. No? So, what is the first type of factorization? 2b, what is this? Minus 32. 2b squared. Thank you. What is the first type of factorization that we looked at? Grade 11. The first type of factorization is in your notes that I gave you there? Highest common factor. So we first need to, although we're busy with this difference of two squares, we always check if there's a highest common factor. That's why I told you, look for that one first. If it's not there, then you go to difference of two squares. If there's not a difference of two squares, then we go to number 3, which is trinomial. Alright, so we can see here that there is first a highest common factor. What is the highest common factor? 2. I take out 2, what it remains? B squared. Negative 32 divided by 2, grade down, it's 16. Now I have a difference of 2 squared. So then within the brackets, I can simplify this. The square root of b squared is equals to b, no? And the square root of 16, 8 times 8 is 64. Oh, okay. Don't get confused there, no? It's the square root. There's a plus sign and there's a minus, and then we're done. The 2 stays outside. Yeah. Good. Here at number E, we have negative 3x squared plus 27. Now, neither of these numbers, 3 and 27, are square numbers. You know what square numbers is, right? For those of you who don't know, square numbers is, for example, if I take the number and I multiply them with themselves, like the first few square numbers, I'm just going to do the first 10. The first one is 1, and then 2 times 2 is 4, then the next one is 9, then 16, then 5 times 5 is 25, then 6 times 6 is 36, and 7 times 7 is 49. Then after 49 I have 64, and then after 64 I get 81, and then the last one, the 10th one, not the last one, the 10th one is 100. So these are square numbers because if I put them under a square root, I get a surd. So I can say 1 times 1, 2 times 2, 3 times 3 is going to be those answers under a square root. Alright, so 3 is not a square number. But I said now, when we're talking about factorization, what is important? We first always check for common factor. Highest common factor. What is the highest common factor between these two terms? 3. So we're going to take out the negative 3. That is my highest common factor. Negative 3. And then what remains? X square. Positive 27 divided by negative 3. What is that answer? Negative 9. Negative 9. Now within the bracket, what can you identify there? That's good work, grade 10. So we can identify that there is a difference of two squares. The 3 stays outside, the negative 3 stays outside. When I'm doing a difference of two squares, I have the square root of the first one and the square root of the second one. That becomes a plus 3, that becomes a minus 3, and there's my answer. Good. So that was the few examples that we're looking at. I think we're going to do the question number 5 now, and then we're going to have a few learners doing it on the board. No? So I'm first going to give everyone a minute to try it now, and then I think that's all we're going to have time for today.